All right, we're going to do some definitions for some pretty crucial vocabulary words and terms that you really can't be successful in a geometry course unless you know these terms. So I realize this isn't your favorite, but just bear with me. We're going to start with some basics. For example, what is a point? Well, a point is quite hard to define. It's actually one of the undefined terms of geometry. Points, lines, and planes are the three undefined terms, which means they aren't defined by anything else. They are what defines other figures. So a point is merely a location. That's what a point is. A point is a location. A point is physically shown as a little dot and is always labeled with a single capital letter. Pretty important, because if you use a lowercase letter, you're actually naming something else. So be very careful. You must have a single capital letter. A line is a path with no start and no end. It's basically an infinite path. It's an infinite path with no width. You cannot actually measure how wide it is. You can, and it goes on forever in both directions. So a line is always shown with arrows on both ends, showing that it does go on forever. A line can be named in two different ways. Remember I said that you got to be careful about a single capital letter? Well, lines can be named with a single lowercase letter. For example, if I put a cursive looking lowercase l, then we would call this line L. So it can be a single cursive lowercase letter, or another way that you can name a line is with any 2 points on the line. So for example, if you had a point A and a point B, you could name this line AB, but it has to have the line symbol on top, or since order doesn't matter, you could also call it line BA, as long as you have the line symbol on top. In a minute, we're going to discuss what happens if you leave the line symbol off. Geometry labels are very, very particular. So it's a single cursive lowercase letter or 2 points with the line symbol on top. So that's how you name it. A plane is a flat surface extending in all directions forever. A flat surface that extends in all directions. Now, since planes and lines go on forever, these are not really things that we can draw very well. So a plane, you usually see drawn like something like this to kind of give it a 3D look. A plane can be named with an uppercase cursive letter. Okay, so this could be plane R, because it's sort of cursive looking. Named with an uppercase cursive letter, or now, and also you'll know that that's the letter like plain R because you won't see any dots next to it. Or you can name it with 3 points in any order. So you could call it plain ABC, You could call it BCA. You could call it CBA. You have a lot of different possibilities, and they're all actually naming the same plane. Or 3 non-collinear points. Now, the word non-collinear, probably going to need to define that word for you too. So let's scoot over to the word collinear. Collinear. Co means with, linear means line. So basically collinear means on the same line. It refers to points. Collinear, points on the same line. So backing up, if collinear means points on the same line, when I asked you to give me 3 non-collinear points, you've got to give me 3 points not on the same line. So let me show you what that means. So for example, I would say A, B, and C are collinear, and I would say A, comma, B, comma, C are collinear. Notice I put commas in between them. If I don't put commas, it looks like the name of a plane, which are 3 capital letters together. So the commas are pretty important. Now if I throw in this extra point D, I can say A, B, and D are non-collinear because they are not on the same line. If you look at A, B, and D, take a look at them. A, B, and D, they're not on the same line. You can't get one line going through all 3 of them. So that's what you call non-collinear. Now the next word is also going to look kind of obvious, I think. If collinear are points on the same line, coplanar, want to take a guess? Points on the same plane. So basically, for points to be on the same plane, any 3 points are collinear. So any 3 points I give you, like the ones from the previous picture, any 3 points are on the same plane. If you can make a triangle out of them, they're on the same plane. Okay? Now, if I were to put a point down here, indicating that it is sort of hovering below this plane, then it would not be coplanar with the other 3. Any 3 points are always coplanar. And these are words that we're going to talk about a little bit more and use a little bit more, especially coplanar, when we start talking about 3D objects that actually are created with separate planes. So we're defining the word now, just so that when you see it come up in a little bit, you're not going to be totally shocked. But it's not going to come up for a little bit. Segment. Segment, I'm fairly sure that you are familiar with. A segment is actually part of a line, and it has 2 endpoints. So a segment is all of the points on a line between and including 2 endpoints. So for example, I could call this point X and this point Y. So how am I going to indicate that I want just the segment XY and not the whole line XY? Because if you look back at how lines are labeled, they are also labeled with 2 points. The difference is that when you label a segment, you put the segment symbol on top. So this could be XY, or this could be YX. They just have the segment symbol on top, no arrows. That means we're talking about a segment. So we name with the 2 endpoints. And blank, this little blank is supposed to be the segment symbol on top. Something pretty darn important that we're going to add in here. So important that I'm going to change colors. You don't have to change colors, but I'm changing colors. Okay, if you just write the 2 endpoints with no bar on top, no line on top, no segment symbol on top, that is referring to the length from X to Y, or also known as the distance from X to Y. So whereas XY with the line on top refers to the drawing, XY with no line on top is actually a measurement. So when you see no line on top, you know that you're supposed to give me a number, a measurement, and that's something we're going to go into tomorrow. All right, midpoint. Let me go back to my other color, just because I like it. Midpoint is kind of one of those words that I probably don't need to define for you. It's a point, and it's in the middle of a segment. So a point, not the same color. In the middle of a segment. Has to be in the middle of a segment because, frankly, lines don't have middles. They don't have ends, they don't have middles. So if you have a segment, let's go back to XY like we had in the previous problem, and we'll just call M the midpoint. So M could be the midpoint. Now it's a point, so it has to be labeled with one capital letter. Now, my drawings are not perfect, and I did not get out a ruler to make sure that that M was exactly in the middle. So there has to be a way to convey to the person looking at your diagram that M is in the middle, and they can trust that M is in the middle. And the one way that you're going to do that is you're going to show with tick marks. Tick marks show that the distances or the segments on either side are the same measure. To be in the middle, that means that the distance from X to M has to be the same as the distance from M to Y. Because if M was closer to one side than the other, then it's not going to be in the middle. So if M is the midpoint, there's a couple of things we know. We know, and I'm pretty sure you've seen this symbol before, we know that XM, segment XM, is congruent to segment MY. That means that the two segments, that basically that midpoint M cuts XY into two congruent segments. What does it mean to be congruent? Congruent. It means having the same measure or equal measures. So if you see that two segments are congruent, you know that the two measurements will be equal. If the segments are congruent, the measurements will be equal. You'll hear me say that quite a bit. And the last definition is a segment bisector. To bisect. Bisect means to cut in half. Think about the word dissect. When you dissect something, you cut it. And the prefix by means to. So dissect means cut, by means to, bisect means cut into two. And more specifically, cut into two equal pieces. Okay? So segment bisector it could be a point, a line, a segment, a plane, or anything that goes through a segment's midpoint. Okay? If it goes through the midpoint, it's cutting it in half. So for example, I could have this little segment hanging out right here. Here's XM again, or excuse me, XY. And then I'm going to take this line and whoosh, I'm going to cut through that segment with this line. If that line goes through the midpoint, then this line, let's call it line L. That means line L is a segment bisector. Line L bisects segment XY. Line L bisects segment XY. It cuts it in half. So if it bisects, so we know that M is the midpoint. We know that XM is congruent to MY, and that the measurement from X to M, if I actually were to take a ruler, would be equal to the measurement from M to Y. Now, all of these we're going to need in our upcoming lessons, so keep this in your notebook so you'll be able to look back on it if you ever have a question what a midpoint is, or how to name a line, or how to name a segment. Now I can't find how to turn the recording off. Hold on, let me get a second.